Testing, testing. Testing, testing. Okay, hello class. It's been a while. I don't really, so we're only like a week away from the test. And like, there's a lot of things that I know that we haven't covered together, and I don't think we will. So if you, like, do your best to learn them if you can. If not, it's like, those, yeah, just honestly just wing it. Like what else could go wrong, you know? All right, listen. You were taught this, so like, there's nothing else to blame, you know? Like, there's no one else to blame. Don't feel bad at all. Like, just do your best. Do your best. Like, there's no one else to blame. If you can learn it, of course, learn it. But like, I think you guys know like a good chunk of the exam. And like, even if you don't know the stuff, try to practice like the problems and just see how like people do it. You know, it's like how can I put this? Like, if you're trying to do 1 plus 1, right? Like, let's say like a baby doesn't know how to do like 1 plus 1, right? But they see that like, oh, you have one and you have one that makes two. Whoa! They just copy that process, you know. So if you see like a problem that you're like, you that like we didn't really cover, or like you didn't learn, just try to see how like people would do that problem. And people, as in like, if you watch like these AP live videos, you know, see how like they do it. You know, like they'll like solve problems on the spot, and maybe you can see like the way they do it, so you remember for next time because the problems are like similar. Does that kind of make sense? Yeah. So today we're just doing some like practice problems, and then the rest of the time, hopefully we'll do more practice problems. And I'll just be here as like if you get stuck, you can ask me for help. Um, I'll do my best. I don't know everything, but that's okay. Do your best. Like, things will work out in the end. Okay, so don't stress. Okay, first question. Spend like just spend like a minute looking at this, right? Just spend a minute. Don't do it yet. Spend a minute looking at it. Okay, just don't solve it yet. Just yeah, you don't even need to solve anything, but just look at the problem. What do you think you need to know to in order to like do this problem? Like what would we need to know? Oh, I hear a formula. What'd you say? A logistic differential equation. Think of okay. So you know what a quadratic equation, right? It's like a quadratic equation looks like this, right? This is a quadratic equation. A logistic equation is just like another type of equation that has a different formula. That's the best answer I could give you, to be honest. Like, um, so we need to know the formula, right? Well, what's the formula? That's the formula. Okay, if you're writing this down, that's good. But okay, but let's just look forward really quickly. So this is the formula, right? Notice how there's a well, this is in terms of p, but the p. Think about the p as the y from the previous equation, previous question. The p is basically the y, right? So I'm gonna go back to the question, and we're gonna like eliminate answers that are like that are. We're just gonna do process of elimination right now, right? Okay. So knowing that formula, which one can we automatically cross out? All of them except D? Okay, we'll take it one step at a time. A is clearly wrong, right? Yeah. And you could also, like, if you had no clue about the formula, you could have also been like, okay, well, A looks like the most outlier one, right? And that leaves you with these three. And a logistic differential equation has like this y over some number in it. So B and C are wrong, so I guess we're just left with D. Yeah. Bye. Bye, guys. Good luck. P
you
is,
guys play?
is Y.
Here or away?
Away.
You're not going.
And again, like, once you know the formula, it'll be kind of straightforward. Does anyone need me to go back and write so they can copy down the formula?
Wait, someone else isn't here. Vinny and
And
Vinny and who? Vinny and who?
Damien, I think that's his name. Damon, yeah.
Is he here? Oh, okay. Vinny and Damon.
Again, like we didn't really spend a lot of time covering this, so don't, don't kill yourself over it. You'll be okay. Try to do problems similar to it. Like it all comes down is just to like be familiar with the problems, and it'll just be the same steps every time. I'm gonna move on to the next question. This one, again, spend like 2 minutes looking at it first. I'm actually gonna give you like some time to try to do it yourself. So here, spend 2 minutes trying to do it yourself, and then I'm gonna go over and give you like a hint or like some direction, and then we can try it again. You guys need me to zoom in, or you guys can see that? I can make it a little bigger. Okay, spend about like 1 more minute trying to do it yourself, and I'll try to give you guys some direction.
Aren't BHC the same problem?
Nope, they are not.
Oh shit, never mind.
Okay, I'm gonna try to give you guys let's talk about this a little bit. So what type of series is this? What type of series is it? Alternating? I hear a lot of alternating. Does everybody like agree that this is alternating, right? What does an alternating series mean? It goes like plus minus, right? So if that's the case, what's the problem with number 1? It's not alternating. If let's say our n is equal to 1, right? This would be negative 1 to the power of 5, so this is negative 1 over 6. Yeah. Wait, and then let's see, if n is equal to 2, that's 4 plus 7, or 4 plus 3 is 7. So if n is equal to 2, this is 4 plus 3, so this is an odd number, so this is going to be odd, minus 1 over 11. So already the first one is not alternating. So you can just cross this one out. We know that one's wrong. The second thing we need to know is, so if something is conditionally convergent, that means like the series that you're given will converge, and the absolute value of it will diverge. Let's talk about the absolute value part. So if we take the absolute value of B, C, and D, we're left with, for b, we're left with 2n plus 3 over 5n plus 1. We're just left with like this right here, right? Conditionally convergent means that this will, what, converge or diverge? Diverge, right? So does B diverge? B? B does diverge. B diverges because, do you remember the nth term test? Right? The bottom has to be bigger than the top. Or like the limit as n approaches infinity has to be equal to 0. If you take the limit here, this is equal to 2/5. So this does diverge, and this one also diverges because it's a 1 over n. The bottom one down here, does this converge or diverge?
Convert.
I heard it convert. Yeah, converge. Okay, I'm going a little fast, but let's talk about this real quickly. So the reason the bottom one converges is because we're just taking a look at the what's it called, the ends, we're just gonna take a look at the ends, the highest like powers. So if we just take a look at that, this is n squared over n to the 4th, which is also 1 over n squared, right? So that's the reason why D converges, because that's a P series where the power is greater than 1. Yes, Thomas?
Does C converge because it becomes like 1 over n, which is kind of like harmonic?
Harmonic means it diverges.
Yeah, and is that why it diverges at C?
Yes, yeah. So that's why C diverges. It's the same like concept as D, but with C you're left with 1 over n, which diverges. Yeah. So again, conditionally convergent means that after we take the absolute value, it has to diverge. So that means D is wrong. D is not an option. Is everybody following? D is wrong. Okay, so now we're left with B and C. And if you remember from the alternating series, again, conditionally convergent means the alternating series converges and the absolute value diverges. So if we go back, A and D are wrong because, well, A is not an alternating series. D converges if you take the absolute value. But for an alternating series, it converges only if the limit as n approaches infinity is equal to 0. So knowing that, is it B or C? It has to be C now, because if you take the limit of this whole thing right here, this goes to 2/5, which is not 0. So that's why B is wrong. A little confusing, but that's how we're trying to break it down. So the first thing we did was try to figure out which one was. The first thing we did was try to figure out which one was what was an alternating series. A wasn't an alternating series, so that's why we crossed that one out. We also crossed out D. I forgot an arrow, but we also crossed out D because D converges after you take the absolute value. So we're left with B and C. Does this process kind of make sense? It's like this. I can see how it could be confusing a little bit, because you have to take the absolute value and then you have to look at it like normally. But what you need to know is, like, after you take the absolute value, what you're left with has to diverge for it to be conditionally convergent. It's kind of a whack like explanation. Is anyone confused, or like you guys are okay maybe?
Yes.
Again, the more time you spend like doing practice problems like this, the more you'll get familiar with it, and you'll know the steps on like what to do. Okay, this one we didn't talk about a lot, but just do your best. Like, do your best with the knowledge you have now. Do your best to try and solve this one. If you have no clue, that like I'll show you right afterwards. Like I think afterwards, if you have no clue now, don't worry because after I show you, you'll be like, oh, okay, that's how you do it. Spend about like 1 more minute trying to look through this. Okay, spend about like 30 more seconds trying to look through it. Who here is like completely lost right now? A couple of you guys, like that's completely fine. But I'll tell you that this is like a very common like question. Like I'm pretty sure you'll see this on the test, and it's just like it'll be look like very similar to this. Like it'll give you some like series, and then x minus some number, and it'll give you like converges at x equals 9. Okay, but let's talk about it. So, this is all confusing, but the things that we really need to pay attention here to are the x minus 5 and then x equals 9. So I want you to think of, is everybody paying attention? Can we pay attention? All right. First, think of a circle, right? X minus 5, that's the center. That means like the function is moving to the right 5 units. You guys remember from like algebra, like transformations and stuff? That means the center is 5. They also tell you that it converges at 9. So that makes the other side 1. Does everybody agree? Right? Because if that other side's 9, that's 4 to the right. That means it must be 4 to the left as well. Does that make sense? Yep. If 9 converges, this is the important part. If 9 converges, that means everything between 5 and 9 also converges. Does that make sense? Right? That's how it works. Now the last thing that you need to know is actually let's go back and cross out some answers. So I crossed out B and why did I cross out B and D? Angelica, why did I cross out B? Okay, I'm gonna go back. So we know that every number between 1 and 5 and 5 and 9 converges, right? So I'm gonna go back to B. Why is B wrong?
Oh, because 10.
Exactly. There's a 10 there, right? And 10 is not between 1 and 5 and 5 and 9. Does that make sense?
Yep.
Okay, Thomas, why is D wrong?
0 is outside.
0, right? Okay, so that leaves us with 1 and 7. So 1 and 7 are both like, oh, we know 7 is in. and C is 2 and 8, which is like in the middle. Now the last thing you need to know is like the last thing you need to know is that like numbers on like the edge. So like we know that 9 is converges, right? 9 converges. But for 1, because it's on like the edge, we're unsure. It's like not, you can't make an assumption about it because it's on the edge. Does that make sense to everyone?
Yep.
It's like you can think about it like this. Like if you know like these like the less than or equal to symbols, right? In this case, it's just everything that's greater than 1. So if I were to write this as like an inequality, x has to be greater than 1, but less than or equal to 9. That's what this is basically saying. For numbers on the edge, like 1 and 9, you can't be confident that 1 is converges. Does that make sense? You can't be sure, but you can be sure of everything in between it, but not just 1 itself, because you just can't. But does that make sense now?
Wait, how did you know I was in the middle again?
Because x minus 5.
Oh,
That's called the center. Yeah, so you like, this is a radius of convergence, and it tells you that like everything within that radius converges. And the radius is 4 because we're told that the center is 5 and it converges at 9. Does that make sense? Okay, this makes sense, right? Like it's not too bad. If you get another question like this, do you feel confident that you can do it?
Yes.
Yeah? Okay, that's good to hear. Okay. This one, do your best with this one. We didn't talk about it a lot, but do your best. Oh God. All right, pretend you didn't see that, but I can make it bigger. I mean, you will. Okay. Well, you know, nobody saw that. Nobody saw that. Again, this would probably help if you pull out a graphing calculator and try to graph the. Pull out if you have your graphing calculator, try to graph that function in polar, and see how it's graphed. All right. Okay. Let's come back together as a class. So if you graphed it, look at the way like my pen's about to draw this. Okay, so this is like the XY axis, right? If you graphed it, you probably saw that it went like here, it made a circle, and it made another circle on the outer one, right? It followed this exact path. It made the smaller one first, and then the larger one. What does that mean? That means, that means you start out with angle with theta equals 0. Okay, please pay attention. This is like kind of important. So, you start out with theta equals 0, right? Okay, so starting with theta equals 0, it starts to graph it, and then like as theta keeps going up, we make this circle. And that's at theta equals pi. And when we keep going, the full circle, that's theta equals 2 pi. And if you're confused on how I got this, another way you could do it is set this number equal to 0. So you do 0 is equal to theta over 2 sine of theta. And if you solve for theta, theta is equal to 0. When is sine equal to 0? Well, that's at pi and 2 pi. But the reason why I like told you to graph it is because it basically tells you that from 0 to pi gives you this area. 0 to pi gives you the area of the smaller circle.
Oh, let's see.
And that means pi to 2 pi gives you that means that gives you this area. Now if we want to find just the area of the green one, well first let's look at A. A is from 0 to pi, so that gives you the area of the small circle, right? So that's why A is wrong. 0 to 2 pi gives you the area of the whole thing. That's why this one's wrong. Now looking at C and D, C from pi to 2 pi, that's the green one, minus 0 to pi minus the blue one. So that's wrong.
Isn't D wrong too?
D is
Because
wait.
D will give you the area of that little circle.
Oh no, C, I think C is right. 0 to 2 pi, pi to 2. Oh yeah, okay, sorry. I'm okay, yeah. I'm pretty sure C is right. Wait, sorry, I'm like second guessing myself now. 2 pi. Okay, yeah. So C is right because from pi to 2 pi gives us like that green area, right? And you subtract the little area, you're left with that shaded one. You know, another way we could also check our answer. Okay, I'll tell you that I'm starting to second guess myself, but I'm gonna check my answer because I got this from AP Live, AP College Word themselves. Okay, just gonna check my answer really quickly. Okay, I'm gonna play their explanation to see if this helps you guys.
Sine of theta, and we know it's graph between 0 and 2 pi. We're trying to find this shaded region R that you see on your screen that's in between the inner and outer loops. And so if you have a problem like this, you really have to think about how polar functions work and think about how it's going to be sweeping out this area between those two functions. And so a really good place to start on a problem like this is to figure out when this graph is going to cross a polar origin. And so we know that happens when R is 0. So in this case, theta over 2 times sine graph the inner loop both, and then it's going to track just the big loop. Well, what are you going to be left with? You graph both and then take away the outer loop, you're going to be left with just that.
Okay. So I don't know if you caught what he said, but he's basically talking about how like pi to 2 pi is like kind of like this whole area, and if you subtract the smaller one, it'll give you that r. If you're confused, like, it's okay. But like, do you see how we narrowed it down to C and D? Like that's gonna be like the difference maker when you take the test. Like really narrow down these questions. So we know that A and B were for surely wrong. Right? And that leaves with C and D, which are like 50-50. So like if you're unsure, do your best to try and narrow it down. Okay, and the last question I have for you is this one. So spend like a minute looking at it, and you will need a formula. Hold on, before you start solving it, I'll give you the formula because I doubt a lot of you guys know the formula. But just look at it first. And in a minute, I'll give you the formula. Okay. Let's pay attention. The first mistake everybody makes is or it's like a misconception that like people think d2y over dx squared. That's basically saying dy over dt, like the second derivative, it's the same thing as this. That's the first misconception people make. That's actually not the case. This is how you would go about solving it. So you first like find your dy over dx by doing that process up there. But to find the second derivative, you have to take the derivative of dy over dx and divide it by the first derivative of x. So spend a minute to like write this out, and now we can go back to the previous problem and try to solve it. And again, this all looks really confusing, but reading this, dy over dt means the derivative of y with respect to t, meaning you just take the derivative of the y function that has the t variables, right? Yeah, I'm just giving you guys a minute to like copy the formula down. Okay, a big like trick to like doing this is it's really hard to take the derivative of this because it's like you have to use quotient rule, right? But if you break it up, if you simplify this and break it up as t over 2 minus 4 over 6t. That eliminates using the quotient rule. If you just like simplify it like that. And you can actually simplify minus 4 over 6 to 2/3. And that makes the next step a lot easier. Plus 6 over 9. That's 2/3.
Set up but don't solve.
I got this. Oh my god, look at this. The thing I'm pointing at.
Okay, I made this a little bit more complicated, but all I'm doing is getting the same denominators.
We can find the perimeter of the shape in the graph. Yeah, that's BC. That's a blessing.
Okay. I made this.
You need some help?
Hold on. Low d high minus high d low all over low squared. That looks right.
Yeah, I got a
1/2 plus 6 over 9t squared. 6t. And then 6 over 9 is 2/3. Divide, multiply by this 3t. 3t. 1/2. Okay, I'm struggling with simplifying. Oh wait, I had the answer originally. What the heck? Wait. Oh man.
One.
Low squares.
3.
Not easy to solve. Somewhat impossible.
Okay.
Number D.
All right, the answer is D. Did anybody else get D?
What? Who's the D?
It gets really okay. Like it gets confusing at the end, but all it comes down to like after this part, you may have gotten stuck, and it just comes down to getting the same denominator and then canceling things out.
That's this. This part here. How is this?
Yeah, just the bottom.
So I did have to
Okay, who like ran into a problem with this one? Like, I can look at your work and.
Oh no, I'm good now.
Oh, you're good now? Yeah, it's.
I can make it look nice if I want.
The wait, did you get stuck at the simplified part?
I can stop anytime.
Yeah, that one's.
Anything.
I can see how you got stuck. Yeah. Okay, that's actually all I have for you guys. We're gonna spend the rest of the time. We're gonna spend the rest of the time just doing practice problems. Oh, good luck. Good luck on your APs. Do your best because it's better to know that you did your best than knowing that like you could have done more. Right. So, give your all. Give your all.